Okay, good morning. Can everybody hear me?
Good morning.
Good, good, good. Welcome, welcome to this group. So a quick introduction. I'm Eric Daben. I work for the Data Science Campus for the ONS in the United Kingdom, and I've been involved and supporting this group for the last 4 years, and particularly, of course, with my team Alison, and of course, very much with In-Kyun Choi from the UNECE in Geneva. So over the next 90 minutes, we will introduce the work of the ML group and the activity program we put together over this year. And we let you know what membership involves and how you can take part in the different activities. We will give out lots of information, and there will be also lots of opportunities to chat and ask questions and contribute. Just raise your hand or put your question in the chat, and then the team here will pick that up. So we're recording the session for those people that can't possibly attend this morning, or they will have other engagement, and it will be made available to the usual channels on the UN website. And we also will be shared outside. So for anybody that actually can just understand and appreciate what we're doing here. A few quick housekeeping rules. So as I said already, the presentations will be made available. The speakers are presenting, of course, on behalf of the ML group, and any views expressed maybe not necessarily represent the organization. So we always want to bear that in mind. And very important that we hear from you, have questions. So please use that Slido code #2909 223 or raise your hands during one of the sessions. We have a very packed schedule, so we're really going to try and endeavor to stay within the time. So when I introduce the speakers, we'll go straight to the speakers, and then 1 minute before the speakers finished for the set time, my camera will be put on again. So just to make sure that the speaker has a little bit of notification to start to round up the presentation. And this is very much in respect for the speakers after that we do not run out of time. We also ask that if you're not speaking, maybe put your microphone at least on mute, and also feel free to have your camera off, and we just focus on the speakers as possible. So if we can start with the first question there. So we see it on the just need to so which country are you joining from? So please go to Slido. I think most people are now familiar with working with Slido, and it's very simple. Just put the country name in, and then we'll start shortly seeing a word cloud developing on the countries that are taking part. And this is really interesting for us, because last year I think we're getting closer to 40 different countries when we're doing this seminar. So I'll give yourselves a few seconds. I'm just checking if we see things appearing already. Okay, we're just switching screens here. So the screen, I think, is still refreshing, so bear with us 1 sec. Just reload that screen so we can see all the different countries. And it's great to see already all the people coming in on the call. There we are. Excellent. Okay, that's great. I think we'll keep it open in the background. And if we could go back now to the slide, and then I would like to take that opportunity to introduce Take. Take and myself have been working for a long time together. It's good to have the support from Take and the whole team. So Take Geltema, he works for the UNECE in Geneva, United Nations Economic Commission for Europe, and he's the chief there, and actually driving, of course, and supporting this work that we've been doing now for 4 years. So thank you, Take. I'll hand over to you.
Yeah, thanks, Eric. And I would like very much to welcome all of you in this machine learning webinar from the side of UNECE and the high-level group for the modernization of official statistics. So I see we have people from New Caledonia, Pacific, Nigeria, Turkey, Lebanon, all over the globe. So it's very good. Austria, sorry. Australia is maybe a bit middle of the night. So I'm very happy that all of you are here. So the HDMOS, or Modern Stats as we brand it, started the machine learning project in 2019. So the HDMOS is a UNEC framework. It is led by 13 chief statisticians, amongst which Sir Ian Diamond from ONS, and the main goal is to modernize official statistics. It's in the name. So I won't go into further details about it, but if you want to know more, you can just type in Google HDMOS and UNEC, and I'm sure you will get a lot of links with further information. Now, under this HDMOS, we work on a topic for maximum of 2 years. But we have limited resources. We always have new priorities. So yeah, we cannot just continue keeping working on the same topic. However, often there is a need and a call by many of you, by many of our colleagues, to keep the work going. This was especially so with our machine learning project, where a lot of people were very active and they felt we shouldn't stop yet. So under the HDMOS, we also have the Blue Skies Thinking Network. So this is the group that is working on proposals for new areas of work, and that group wrote a concept note for setting up communities of practices. Now, Eric, who just spoke, was also part of this group, and we were extremely happy that he and his team at ONS offered to support the follow-up of the machine learning project, which led to the great group on machine learning to be able to continue. So again, great thanks to you, Eric, Alison, and all other colleagues at ONS that have been involved in the past 2 years. And also thanks, of course, to Inkyung to keep being involved from the side of UNEC. She did all the work. I'm sitting here, but I didn't do hardly anything there. So, of course, this machine learning group can only work if all of you are collaborating and sharing your experiences. Otherwise, we don't have that community of practices, and otherwise we cannot jointly develop further competencies in these areas and new methodology. So before I hand over back, we are short of time. I want to have as much as possible attention to machine learning and not to me. So I'd like to end this with thanking all of you, especially the presenters today, for being part of it. And I wish you all a very good and fruitful webinar. So back to you, Eric.
Thank you very much, Tak, and thank you for those very inspiring words, and to have that support from the UNEC there. I think that's really important that we've been able to pick this up jointly, but of course it always comes down to the participants, and I think we can see that today again with so many people already joined us. Of course, we got the 2 sessions as well for this morning and this afternoon to cover, of course, the quite broad time span we try to do here. Okay, so we'll go. I'll give you a few minutes, only 2 minutes, just an introduction. And then we actually start to the real interesting part of the day, to listen to the presentation and the feedback. Okay, so as we said there in that opening line, I mean, machine learning is really to train and actually to help us to look ahead what we could do with statistics. And I think we really identify that over the last couple of years. It's not just going to replace producing statistics, but it's definitely helping us. I think that's very important for us, that we can continue on that. And as we look at this model here, that many people will recognize, the GSPPM, and the General Statistic Business Process Model. And then if you look at, say, at number 5 around process, we really identified a few steps that we can actually start to replacing and then almost automating a certain manual process with machine learning. And this is really helping us, and this is helping us for many different angles. It helps us, for example, to speed up the production of statistics. This can help us sometimes even get a better accuracy. But it's not at all to replace what humans do, and we often call this the humans in the loop. So we will continue to need that. I think while this group keeps on growing, while the technology will be improved on years to come, we will find more areas, particularly in this GSPM. I think looking ahead, that we can see being replaced by automation. Of course, I think automation is a way forward to make sure that we continue to produce relevant statistics. Next slide, please. So what do? So in this group, of course, with over 400 members now, it's very much on a monthly basis. It's actually when you come together and do that knowledge sharing. But the real work really happens in the background. And actually, when the smaller teams, the smaller work packages, work streams, or team groups, as we had this year, actually start to identify possibilities. And as we often said already from the beginning, like it's great to work with the different organizations together, because we're not in competition. We try to really for our organization, for our government, to produce like relevant statistics. And the way to do that actually is to work together and actually try to find innovative ways, because I think we have very similar challenges. So the way to do that is through knowledge sharing, to very much do that research and that collaboration. Actually, how can we take this forward? How can we take it forward from that theory that we had to look into, now put it into practice? And of course, and then you start building that capacity, which we've done to many different ways. Of course, we did the very popular coffee and coding session. I think this was probably one of our top sessions all the time, because people had such an interest to learn at first hand from practitioners in the field what you can do and what you already can learn in like in an afternoon session. And of course, there's many also available resources available on the, of course, the Uni Wiki website. Next slide, please. So for this year, we had, of course, the priority teams. I think we had over 30 actually interest in this year. We broke it down in 7 different groups. And then, of course, that's today's objective, really, to really look into the detail for these 7 groups and what I've done. And you can also see, like when we started in the beginning 4 years ago, we initially very much focused on the technology itself. But now, of course, lots of different areas came part of that. I mean, we have a whole session around infrastructure. What kind of infrastructure, what kind of cloud do you need? How do you build it up? How do you make sure that your training data will be improved all the time? What about model retraining? I think these were quite topics that we just realizing over years that became very much part of that ML technology if you want to implement that in your organization. Next slide, please. So what actually do our members say? So a few quotes here. I think we can all just read them all there. And it really, I think, opened this for us to 2 years ago when we sat down with Tak and Inge and the group to say, well, we can't just stop this project after being 2 years part of the high level group. We need to continue that. And I think we managed to, of course, over those last 2 years, really grow that membership from, like, I think about 100 when we left the 2 years, and now we are well over 400. And it's not just often about a numbers game and growing the group, but this is also show the interest. And it really showed that it's actually almost just spreading out across the whole world now, with I think close to 40, 50 different nations and countries actually taking part this on a monthly basis for their own unique needs. So it's been a real positive experience for ONS. We feel quite privileged to be a big part of this, and I think this is now also very well recognized across many conferences. And I think that this shows the big interest for this. So, and our next step really is, of course, to make sure that we continue to put this at the very senior and the top of the office agenda, and even into our governments, that they can see the potential of what machine learning can help them actually to drive policies, to inform. But of course, the main objective always needs to be, how can we help the public and actually the users for this? So with that, and I really like to take the opportunity now to start talking about the team groups. So the first one we're going to have, and what is the role of ML on visual statistics? I outlined that. I think the first one this morning we're going to talk about is web scraping. So web scraping was very much led by our colleague from Stats Vlaanderen, Mike Rosen, and I think web scraping is probably one of those areas that is probably comes up almost like in most conversations when you talk internationally. Is quite an easy way, if you like to think it that way, to get involved into machine learning. So we're going to have 25 minutes. Mike is going to lead that. He's supported by Claudia Pesket from Stats Poland and also by Bilal Kurban from Turkstat. So with that, I just want to hand the floor to Michael to give him the opportunity to do a quick intro, and then actually that we can listen to his presentations and his team. Thank you very much, Michael.
Great, thank you, Eric. Just to check, can you hear me and can you see my slides?
Yeah, we can hear you. I can see your slides very clearly. Thank you, Michael.
Oh, that's perfect. So thanks very much for the introduction, and also thank you for the organization, you and your colleagues of the ML 2022 project. Me and my two colleagues from the web scraping team group, Bilal and Claudia, will give you an overview of the work that we've been doing on the team of web scraping in the context of ML 2022. I work at Statistics Flanders, and there I'm a senior data scientist, and I'm the coordinator of the data science hub of Statistics Flanders. In this talk, I'm going to talk about like why we felt there was a need to have a separate web scraping team group and what we did in that group. Then we're going to talk about 3 use cases, or use cases that we've been developing in 3 different statistical institutes. Turkish Statistical Institute, Bilal will cover that. Claudia will talk about the use case that she's been working on in Statistics Poland, and I will talk about a use case related to web scraping that I've been working on in Statistics Flanders. And I'm going to wrap up with some concluding remark and by summarizing our key takeaways. So, as Eric indeed mentioned, there's lots of attention for web scrape data in statistical organizations, and it's easy to understand why. I mean, if you can find a piece of information openly available on the web, you can scrape it or retrieve it as many times as you like, meaning that there's opportunity for super high frequency statistics. You can also cover a lot of information. You have access to a lot of information that you don't have access to with traditional data collection methods like survey or administrative data. So that leads to a great quality improvement potentially. And on the other hand, I think we're all observing drops in response rates, that people are less and less likely to respond to our surveys and traditional data collection methods. So if we can scrape something from the internet rather than having to ask people about it, I think this is a great opportunity to lower survey burden we put upon our society. So those are just 2 of, I think, the most prominent opportunities of using web scrape data for statistics. So we're all very excited about using it, but we also have a lot of questions about it. So yes, okay, I'm convinced there is some opportunity there, but how do I actually get started? And the key questions there are about like methods, like technologically and methodologically. How do I actually do it? How do I actually get a statistic as a result? Secondly, there's lots of quality issues. I mean, we venture often into new terrain. Often these are new data sources being tapped into for statistics productions. And with anything new, lots of questions pop up around quality, like the accuracy, the biases, ethical issues, privacy issues. A lot of questions pop up in our organizations. So this is why we started a team group. And the goal of a team group was to make sure that we can facilitate statistical organizations in their adoption of web scrape data. We want people to use web scrape data for statistics production. That was, in a nutshell, our goal. Well, we wanted to help a little bit. Of course, we won't achieve it completely just in our team group. We did it in 2 ways. We had monthly meetings during which we had knowledge sharing. So experts and speakers were invited during the year to talk about both basic introductory topics around web scraping, so organizations with no prior knowledge could get up to speed, but also very advanced topics were discussed. Secondly, 3 organizations, and that's Poland, Turkstat, and Statistics Flanders, implemented their first or one of their first web scraped data use cases in the organization in parallel and gave each other feedback along the way. So with knowledge sharing topics that were discussed are about where do we start from as a group? So we're not the first activity related to web scraping in official statistics. For example, there were prior SNETs that were organized on web scraping company information. So that's the first thing we did is we took an overview of like, okay, what's already out there, which pieces of code, which reports, which guidelines should we start from, as to not reinvent the wheel. There were many organizations that visited our team group to present use cases that they did in their organization. We talked about advanced natural language processing techniques. I think when we talk about web scraping, most often you scrape pieces of text from a website. So the topic of natural language processing and text classification is highly associated with our team group. And then we also discussions on quality issues, like how do we make sure that, yes, we can do it technically, you can go from a website to a statistic, but how do you know if it's any good, if it's of high quality? Those topics were discussed, and many more. And I feel that by discussing these topics and by doing such an amount of knowledge sharing, all the members of the group really upped their game and got a lot of knowledge about doing web scraping properly. The second activity was the parallel implementation. So as mentioned, we were 3 organizations that committed themselves at the beginning of this year. Okay, yes, we're gonna actually have a web scraping result by the end of this year. And I think we all 3 succeeded. And I'm gonna give the word to Stats Poland and Turkstat just in a second to discuss their use cases. What was nice about it is that all 3 implementing organizations were relatively new in the domain of web scraping, so we didn't have much experience. But by doing it in parallel, even though we didn't have exactly the same use cases, and by feeding back our status updates each month during the monthly meetings, it was good to see where the roadblocks were, where the successes lie. And we often noticed that, yeah, we're all facing very similar issues and we're all asking ourselves the same questions. So it was a great help to do this in parallel with our colleagues from Stats Poland and Turkstat. Now I'm going to give the word to Bilal to discuss his use cases at Turkstat. Bilal, are you there?
Thank you very much, Michael. Can you hear me?
Yes, perfect.
Thank you. Hello, everyone. I am Bilal Kurban from Turkish Statistical Institute. First of all, I would like to thank you, Michael, from Statistics Flanders and Claudia from Statistics Poland. I learned a lot while working with them. And thanks to ONS and UNECE representatives Alison and Inkyung for this collaboration opportunity. And as an implementer in the web scraping team group, I carried out 3 projects. First one is the scrape an ICT variable, and I tried to obtain an ICT variable, namely social media presence by web scraping. And at the end, I compared the results with the Turkstat's actual ICT usage in enterprise survey results. And then in the second project, I tried to gain insights from an open-ended question, and I tried to extract insights from responses to an open-ended question in Turkstat's biotechnology survey without examining individual reports one by one. And in the third project, I tried to create a framework for government R&D survey. Via web scraping, identifying public organizations that use R&D related terms on their web page at least once, and I tried to create a government R&D survey framework with them. Thanks. And next slide, please. Yes. In the first project, here in the project, I scraped all the enterprises having 250 employees in Turkey. And as you can see from the table, I got the results. The ICT variable was the question. The question was that, does the enterprise website have links to its social media profiles? And as you can see from the slide, the results are in there. I got 62% of accuracy. Actually, the most important number here is that 8% is the 89 enterprises, because in the survey they say they didn't have any social media links in their website, but actually as a result of web scraping, I figured out that they indeed have a social media, at least one social media link in their websites. Next slide, please. And in the second project, here in this project, I used natural language processing techniques. And as a result, besides many other findings, I have obtained the word cloud in the slide. The project was about gaining insight from an open-ended question. In the biotechnology survey, at the end of the survey questionnaire, we put an open-ended field. In this field, we are inquiring about this question that we said that briefly inform about the biotechnology activities carried out by your enterprise and the techniques and application it uses. And in the word cloud, you can see that the biotechnology enterprises in Turkey actually talks about or mentions about these issues, plant issue culture, research and development, high value added, food supplement, real-time PCR, etc. Next slide, please. And in the last project, I tried to create a government R&D survey framework. The government R&D is a full census survey, not a sampling survey in Turkey. Therefore, we create the survey framework by ourselves. And in order to select units to be included in the survey framework based on an evidence, I created a Python code which takes the R&D related terms and the list of URLs which belongs to government units like hospital, ministries, municipalities, etc. as inputs. And then the code scrapes all the enterprises, not enterprises, all the government units. And then at the end, it produces the links with the terms in the output. And in conclusion, with this project, it's possible to learn which government units mention R&D on their websites and how often. Thus, we have an evidence-based knowledge of whether to include them in the R&D survey framework or not. At the same time, since this is a generic application, it can be used easily when certain terms are searched on a specified web pages. That's it from my side. Thanks for listening.
Great, thanks, Bilal. Then I'm going to hand it over to Claudia from Statistics Poland.
Thank you, Michael. Good morning, good afternoon. My name is Claudia Poszat. I'm from Statistics Poland. And first of all, I also like to thank Michael and Bilal for a great cooperation within machine learning group, but also with my colleagues from Stats Poland, Dominik, Emily, and Bartek, who are also collaborating with me, and we are doing this use case together. Our experimental research was aimed to calculate the number of companies undertaking activities in the field of corporate social responsibility. The acronym is CSR. We firstly defined the CSR in very generic way as a corporate responsibility towards the community and environment in which it operates. We haven't considered any specific activities within CSR. Our aim was just to classify the companies into two groups, those which carry out activities in a CSR field and informed about it on their web pages. And the second group, those which more likely don't have any CSR strategy, or at least don't communicate about their activities in this area. Next slide, please. During the project, we have been following the very similar pipeline as was implemented by Bilal and by Michael. So first, we start by preparation of the population of companies. We used our statistical business register, and here we've also have to make some strategic decisions. We decided to take into consideration only medium and large companies, and as they are more likely conducting that kind of activities, and they also have web pages, which is not always the case of small companies. So here we've got to prepare the input data and gather from our business statistical register URLs for the companies. The second step was web scraping. However, we take a different approach in that step, as taking into consideration the enormous variety of structure of website, we decided to use just a internet search engine to find text which refers to the CSR on the company's web pages. And here we've also had to make some decisions, which phrases we will put into search engine, how we find them, which search engine we will use, and so on. So here were also some dilemmas. The next step was data preparation and pre-processing. So here we removed from our data sets the pages which were irrelevant. So for example, yellow pages, social media, also social campaign pages, which were found in our search results, and also applied some pre-processing techniques. Finally, we have a data set which were prepared to modeling. We use an unsupervised modeling called top2vec, which aim was automatic detection of topics for our results from search engine, and then also assess the results of the modeling. And can I please next slide? And we can see the library provides very nice visualization methods which enable us to assess the results. So first of all, we've got the word cloud for the topics. We achieved 73 topics, but one of them was really closely related to the concept which we were looking for, so the CSR activities of companies. Here we've got mainly Polish words, but they relate to society, strategies, environment, sustainable activities, and so on. So these are very closely related to the words and to the concepts which we were looking for. And what is also really important, that the topic actually consists of the highest number of texts from our data set. So the cluster was the largest from comparing to the to others. And we've got also some more specific tools to assess our results. So for example, we've got a score for each document, and which assess the similarity of each text to the topic. Which we can also further investigate, for example, in the scatter plot or in the form of the table, ranking, and so on. Finally, we calculate the number of companies which were assigned to the topic related to the CSR, and the number, it's not so big, it's only 280, so it's 2.5% of all companies which we took in our data sets. But of course, as the topic it's not so common, it seems that this percentage is not it could be relevant. Of course, we are aware that this is just the first step, and some more advanced validation methods should be used to when we were considering moving this experimental research to the production of official statistics, and as well comparing with other data sets. However, in that case, it will be very difficult because, for example, in Statistics Poland, we don't have such information about companies which carry out CSR activities. In other cases, it's more easier to compare data and results from modeling with survey or data which we gather, and I think that Michael also will talk about it a bit. So, Michael, I hand over to you. Thank you.
Great. Thank you, Claudia. Thank you, Bilal. I will now briefly go over the use case we did at Statistics Flanders. Our goal was to develop a generic web scraping method for company activity classification. So what is the activities that a company does? Can we automatically classify them using data scraped from their website? So our goal is to create better company activity statistics, better meaning higher frequency, like better timeliness, higher accuracy indeed, and also lower the response burden we put on companies. So if you can do this well, there's less need to survey companies and bother them with surveys. In general, this is the pipeline that we follow. So we start with 900,000 Belgian companies. This is all the Belgian companies except for one-person companies. So those were considered a bit privacy sensitive, so we excluded them. Out of those 900,000 companies, we had 300,000 known company URLs. So we didn't focus on automatically finding URLs. That's like a separate piece of work. We scraped the website texts from the home pages only. So what we then did is we also used an embedding model that's underlying top2vec that embeds each company text to a point in this space that you see in the slide. And I'm not going into detail, but the clue is that each text is translated to a number of to a vector of to a list of numbers to mathematically represent the meaning of the text. And if 2 points lie closely together in this space, in this point cloud, it should mean that they have similar text, that the meaning of the text on the website is similar. And in our generic approach, which is unsupervised, ideally, we experiment with giving this text a free text, giving this embedding a free text query, like a definition of a concept or of an activity. And we would embed that text query to the same space and see which companies lie closely to our definition. And coming out of that would then come a ranking of companies that lie close or far from that definition. The text query is maybe a bit abstract. So what you, for example, could do, or what we did, is that if you want to automatically find companies who are active in the field of artificial intelligence, you could give it the definition, for example, of artificial intelligence, for example, taken from Wikipedia. This text from Wikipedia would be embedded to this space, and then the closest companies to the embedding of this definition, each company would get a score of how close it lies to the embedding of this definition. Concretely, this looks as follows. Let's say you take this definition from Wikipedia, so artificial intelligence is intelligence, etc., etc. We take a definition, we embed this, and with this embedding, you can query this point cloud, and what comes out of it is a list of a score. And the score, the higher the score, the closer the company text lied to this definition, together with the company number and the company URL. So this gave us an ordered list of, from best matching to worst matching, companies that are likely active in the field of, in this case, artificial intelligence. Yeah, so for, I think there's a slide missing here, but that's okay. So what we're now doing is, if we're experimenting to see, first of all, how good is this list. So this is still ranking, not classification. We're collaborating with a government entity in this space who uses these lists as like lead generation. So the government entity we work with is active in innovation, and they want to know for specific company activities, which companies are active in this activity. So that we give them this list, and they will use them to contact companies. For example, if they want to reach out to AI companies, they will use this list as lead generation for their work. And in the meantime, label this data set. Okay, we try to reach out, for example, to mindtech.com, but in the end, they don't seem to be active in AI, then it will get a negative label. And so they are giving us labeled data to evaluate this method. We try it for artificial intelligence. We also try it for bioeconomy. And by the end of their work, once they've been labeling for a while, we can go back and evaluate to see how well does this generic unsupervised method work for company categorization. So this was, in a nutshell, like lightning speed, our 3 use cases explained. There are more elaborate reports for each of the implementers and for the web scraping team group as a whole, which will be shared via the ML group if you want to know more details on each of these use cases. I want to wrap up by concluding and mentioning the main lessons learned from a group. I think by joining brainpower and joining forces across national statistics institutions, I think we've all got like a huge boost in the back, and we've hit the ground running, even as like relatively little experienced countries in web scraping. So by knowledge sharing, this works very inspirational. You have to know what's possible in order to get ideas for what you want to do. If you share knowledge about best practices and existing pieces of code, like what the prior SNet that I mentioned did, like, great efficient start. In less than a year time, you get some nice results. And then secondly, by this way of co-implementation, that's what I'm going to remember and take forward in my work, is that if I'm going to start a new venture, a new statistic, I'm going to find a partner in crime, nationally or even internationally, as we did now, to make sure that if I hit roadblocks, I can talk about them with my partner in crime, with my colleague implementer, so we can find faster solutions for problems. And it was great that we, as Eric mentioned, we are not competitors. It's even the opposite. We invited each other into our houses, let's say, and even showed us the dirty dishes and the dirty laundry about what the main struggles are that we're facing when doing these type of work. So that's fascinating. It's good to see how other organizations are structuring and approaching these type of experiments. So in general, I think it was a huge benefit of collaboration. So with that, I want to thank everyone who participated in the web scraping data team group, especially the colleagues from Turkstat and Statistics Poland, who took the time to co-implement with us a web scraping solution. And then I want to thank you for your attention. I want to hand it back over to Eric, or if there's any questions, feel free to ask. If tomorrow or at night you wake up and you think, oh, I have this question that I didn't ask, don't hesitate to reach out to me. Here is my email address. I'm more than happy to discuss this further with you. Thank you very much.
Thank you, and big thank you to Claudia, Bilal, and Michael. Of course, this, I think Michael already summarized, and I just wrote 2 points down, and they very much resonate what Michael said in his conclusion. Is three NSOs were new to web scraping, but they work together. So collaboration flows all the way through that, and also in quite a short time, because a year is not an awful long time. They learned a lot, the opportunities that web scraping, and then making ML looking as a technology using for that. But the big main thread through this is really that collaboration and take this forward. So thank you for this first very inspiring session. I now would like to hand over and introduce Inkyun Choi. Of course, many of you will know her, and for the great work she's been doing on this program for the last 4 years. Inkyun works for the UNECE, is a statistician, and of course very much with Alison, the 2 key coordinators for this ML work. Inkyun, the floor is yours.
Yeah, thank you, Eric. Could you first check if you can hear me and see the slide okay?
Yeah, we can hear you, see you, and see the slides.
Okay, so I was told that I need to finish this discussion within a few minutes. So I will try to be selective and touch on the questions that are voted the most because I think some of them, maybe Pilar, Michael, Claudia, you can, if you go to the Slido, you can also reply directly to some of the technical questions. So maybe I will leave those to you. And maybe I will first touch on these questions because it was voted most right now. Have you had any legal issue with accessing the websites? And it seems like it's at the experimental phase. But if you think this experiment goes to a much larger scale, would you expect more like legal issues?
I would like to answer that one. I think the use cases we do are relatively safe legally. You have web scraping cases where you try to like extract all information from one website. For example, you want to get all the hotels at booking.com and you're really gonna squeeze booking.com to get all their data. That's one kind. What we did is we accessed like a lot of websites just once and very briefly, and that's safer. I know that from web scraping, there's still a gray zone in many cases. If you're gonna squeeze one website for all their information, that's sometimes still a gray zone. But for the cases that we're doing, that's legal, even though regulation changes country by country, but those use cases are allowed, yeah, even at scale. Of course, you have to follow guidelines, right? You can't DDoS a company's website when doing this, but generally, yes, they're fine.
So there's another question that voted quite heavily. So congratulations for your impressive work. What are the most difficult or time-consuming tasks in this pipeline? What is the less reproducible part for an NSO wanting to follow your pipeline?
Claudia or Bilal, do you want to take this?
Yes, thank you for the question. From my perspective, the most big issue, the biggest issue I have to deal with was the subpages. I mean, when you carried out scraping websites, the most important problem sometimes to reach the subpages, because if you scrape one page or a main page, it is relatively easy. But when you go from top to bottom, you have to deal with other problems, and sometimes you can get millions of sub-pages. So this is some kind of iterative method. You need to stop going further with the sub-pages. Thank you.
So if I may add something to the Bilal answer, I would add that the most difficult and challenging part relates also to quality assessment of results, as we know that from the beginning of our pipeline, we exclude, for example, some companies which don't have websites. So we don't know if they, for example, conduct some kind of activity because of they don't have websites. So this is the first thing. And following the pipeline, we entered into other methodological and quality related issues on each stage, and of course also in implementing machine learning models and this classification part, which is unsupervised in our case, so we don't have any labels, may also provide some biases, some errors, and this needs further assessment. But in that kind of models, we don't have for example, the assessment and quality indicators as we have in a supervised model. So this is also the thing which we have into consideration.
May I add something? And thank you. And I agree with Claudia. And I should add that when we use machine learning, deep learning, web scraping, or internet as data source, etc., when dealing with big data, and big data requires complex techniques to produce statistical output. Sometimes we can only observe the inputs and see the outputs, but transformation may not be understood. In order to work in line with the professional ethics, NSIs using big data analytics to produce statistical output should not only describe the data sources, but also explain clearly methods and models applied. This is absolutely necessary for building confidence and trust of users in official statistics. Thank you.
Michael, do you want to add something?
I concur with my colleagues, and I think what Claudia mentioned, quality control. Getting this done technically is one thing, but getting the quality control and checks in place is a lot harder than technically. So that's the main challenge that we are still tackling at the moment.
Yeah, I think this application area is really a place where two frontiers meet, like web script data and the machine learning. So I think there's still a lot of challenges and issues ahead. And thank you for this great presentation. And as Michael mentioned earlier, we have a full report that contains more details. So you can also check this, the more details in this report. And it's really great to see that the three organizations had such a fruitful collaboration. So maybe I will stop my screen right now, and maybe Eric.
Yes, thank you. Thank you. I think this created already lots of questions which we continue to capture. And of course, we'll look at those afterwards as well, which is very important that we actually find answers for the very important questions. So now we're going to look at our three next different teams, and we're going to start with Inkyun. So it's three short presentations, about 10 minutes each, again, followed at the end with question answer. So capture your questions or put them in the chat, and then we'll do another 10-15 minutes at the end of these three presentations. So start with Inkyun, and Inkyun is going to share what we learned this year around text classification. Inkyun.
Yeah, back to me again. But this time I'm going to present about the text classification theme group. Before I move further, could you confirm that you are looking at the slide saying ML 2020 text classification?
That's correct, yes.
Okay, thank you. How do I move? Okay, yeah. So just to give a little bit of an introduction for those who are not familiar with the text classification in the context of a statistical organization's work, it is a task of classifying text written in natural language into a code in the statistical classification system, or some predefined code list in organization. For example, this survey response, I'm a cook at the Italian restaurant, is coded as a 35-2014 of a standard occupational classification, SOC. And this task is very important for the work of a statistical organization because it allows the data to be systematically aggregated, disaggregated, and compared in the downstream task. And as we just saw in earlier session, there are so much information exists in the textual form on the web, and many statistical organizations are looking at web as a news data source. And to use this information on the web, as you saw in the presentation earlier, we also need the text classification. And traditionally, this text classification in the statistical organization used to be done through a complex rule-based system or done manually by human coders by reading the description and finding the code in the classification system, which are quite resource intensive, both in time and then in code. And with the advance of natural language processing and the machine learning techniques, this task now can be automated or done in a much more efficient way, which in turn can help statistical organizations make use of new data sources, such as web or social media. And as Taken mentioned briefly earlier, we had this form of international machine learning collaboration since 2019. And the first 3 years, we had run a pilot study in various different working areas of a statistical organization. And this text classification was always the most popular application area, which I think really indicates the viability and interest in machine learning-based text classification among many statistical organizations. And this year, we moved the focus of collaboration from running pilot studies to providing a platform where people working in different organizations bring the projects that they are working on to share experiences and discuss about the common issues and challenges. And this is a high-level overview of the presentation made throughout this year. We had the presentations from Brazil, IMF, Canada, France, Mexico, and Belgium. And although these presentations were on different use cases and different types of data, there are some trends and common lessons learned that we observed in multiple use cases. So for the rest of this presentation, I will go over 4 key observations. The first one, maybe this is more like a reconfirmation, which is that the application of machine learning for textual data from survey and the web is a still very solid use case. So it reconfirms that machine learning based text classification is here to stay. But we also saw how machine learning can be used outside this usual production area and also to provide a service. For example, in the Statistics Canada's case, they use machine learning to develop an email sorting service for another government agency, so that the customer queries can be sent to right agent more efficiently. And in the example of Statistics Flanders, they could provide a list of AI companies to other government agencies based on their web scraping data analytics. And these days, statistical organizations are increasingly asked to transform from a data provider to a service provider. And I think this machine learning capability in this area can really offer a great potential for statistical organization to provide a data-based services. But one difficulty for many statistical organizations, actually, I think it's for many organizations, regardless of a domain, is that this machine learning field changes really fast. So it's quite difficult to stay up to date. Even a few years ago, methods like random forest or TF-IDF, they were quite popular. But these days, they are still used as a baseline, but they are being challenged by more recent methods like word embedding based methods or transformers and so on. Now, this raises a question that, is it worth changing to more advanced methods whenever it comes out when existing machine learning models work just fine? And actually, in our first meeting, we did a very quick survey among the meeting participants asking about their experiences of using more advanced methods compared to the classical methods. And most of people said actually the performance was similar or even worse. Now, this initial observation, we could validate and discuss about this throughout the year in the multiple meeting. So in the end, I think it's quite difficult to make a general statement that modern method is better than the classical method or vice versa. But there are some factors that we observed that could inform such a decision. First is that if the target text is relatively long and complex, more advanced methods seems to perform better than the classical ones. And this might seem so obvious, but it also explains why most people in the earlier survey said that they didn't see much difference, because still most common use cases in statistical organization for text classification is around classifying job description or activity description from the survey or registers, which tend to be short and simple. But this also suggests that we should pay attention to the impact of training data on the machine learning performance that we observe. For example, rule-based systems, they often rely on the vocabulary level information. And if your training data are from past classification results done by this rule-based system, then classical methods such as backup of word, which also often rely on vocabulary level information, they would just mimic what the rule-based system could already do. But we want to do better than what the rule-based system could do. So we need to pay attention to how our training data is constructed. And then one major concern around the more advanced methods is that they are black box. Yeah, Bilal mentioned about deep learning model, which is considered quite black box. But there are tools, at least for the text classification area, like the LIME. It's a local interpretable model agnostic explainer, which was used by colleagues from Brazil. This kind of a tool could shed light on the result from the machine learning model. which can also assist in validating the prediction made from the black box models. The next point is around the class imbalance. In the classification, the prediction performance is often poorer for the rare classes because there are just not enough information for the machine learning model to learn for these rare classes. And throughout the year, we have seen several strategies. Some used oversampling, some used adaptive threshold to account for the higher level of uncertainty associated with these rare classes. An interesting approach was to expand the training data using auxiliary information. And the example of in the example from the Brazil, they were classifying a product description into code codes. And for rare classes, they actually add description of codes directly from CodeCo. So this CodeCo is a classification system for the product. And it actually adding this it's a code description from CodeCo were actually helping to improve the performance of these rare classes. But in general, it is quite difficult to make a good performance model for every classes when there are so many classes, which is often the case for text classification. So it will be actually advisable to curate the data set first, for example, by reviewing the data set with the subject matter experts and removing any classes that are not deemed important so that you reduce the number of classes from the beginning. Yes, I see Eric appearing, so I need to be quick. So the next point is around how to move beyond the proof of concept. And this is actually a challenge shared by all machine learning applications, not just for text classification. And this year, I think we saw these concerns around the moving beyond the POC were given much more attention than before. So people in POC stage were already talking about how to move beyond. And several stages were mentioned, which includes having some retraining strategy plan. For example, if you can use confidence level from the prediction to select data to be labeled for retraining. Another was to increase user acceptance, so you can develop user-friendly services, provide explainer like Lime that can help end user to understand the model better, which helps in turn moving your solution into production. So, yeah. So I went really quickly. So we have a full report on the text classification think group on the wiki page, and this report also includes some our Python or R library recommended by the practitioner. So make sure you check it. And that's it. End of question. End of presentation.
Thank you very much, Inkyun. I'd like to go straight to our next team, which is imagery, and that is been led by Joep Burger from the CBS. And we first have a presentation from Joep, and then I think Joep will also have Nova Sharkey from CSO also saying a few words about the work that we're doing around imagery. Joep, it's all yours.
Okay, thank you. Yes, can you see the slides?
Yes, we can see the slides. Thank you.
Okay, so I'll be talking about this imagery group. The overall focus is on the use of machine learning for imagery data, or also called Earth observation or remote sensing. So looking from above and analyzing either satellite or data or aerial images. This research group was targeted at members who already had some experience with working with this type of data. It's quite a large group and a varied group, which is really nice, also from different institutes. So we started out with defining some research questions and looking for open data so that we could work together on a project and apply some methods that we could answer these questions, but this turned out to be too ambitious. So in the end, we decided, we moved on to reading and discussing papers on a number of themes. That is the architectures of the neural networks that are used for image analysis. Also papers on class imbalance and explainability. So on the architectures, we focused on this paper by Zhu et al. In 2017. Yeah, there's different types of imagery data that's important to realize. So there's spectral or radar images, so whether or not they are passively or actively recording information. And there's multispectral or hyperspectral data that's also a different. Yeah, depending on the sensor, you need to consider what you have and how to analyze it. It turns out that these convolutional neural networks are de facto the standard for analyzing remote sensing data, because they usually outperform the traditional computer vision methods. And another nice advantage is that they learn features automatically instead of having to handcraft them. The ResNet seems to be a good starting point. That's a CNN. There's many more, but it's not very clear why it is, because the people are very much focused on accuracy, performance, and not so much on being able to explain why it works. And in the future, maybe the CNNs may be replaced or combined with vision transformers. It's another more new technique, as In-Kyun said. Always new things coming up. On the class imbalance, we focused on this review from 2019, although there was a more recent one, but this is a very nice one. Yeah, one of the measures they use is the ratio between most and least abundant class as a measure for class imbalance. It's not symmetrical, and you don't take into account the entire distribution, but at least it's a measure that you can, a simple one, and you can compare between methods. And these papers, they usually make this distinction between data level methods, algorithmic level methods, and hybrid methods, where the data level methods, they really focus on sampling techniques. So you can either undersample the majority class or oversample a minority class, or make synthetic examples from the minority class. Two-phase learning, so you balance first and then retrain with the unbalanced data. And dynamic sampling is that you sample during your iterations, you adapt depending on how the performance is doing. And in the algorithmic level methods, you can do other things. So you don't change the data, but you change your learning, your model. So for instance, you can adjust the loss function, or the cost-sensitive learning, that is that you treat your false positives and false negatives differently. And output thresholds, that's also what In-Kyun also talked about. So you can not change the model, but change the output in deciding where a cutoff on when you decide it's a positive or negative case. And of course, you can combine these methods, and usually these methods get better, but they also get more complicated. And on explainable AI, we focused on this paper by Gewart, a new one. Important distinctions is these methods, or is it intrinsic? So is it in the model itself, or is it post hoc? Do you try to explain the predictions afterwards? Is it model specific or model agnostic? And global versus local explanation. So can you make a global explanation, or can you explain only specific cases? An important point she made is that these most models are focused on predictive accuracy, but you should actually balance it with the descriptive accuracy. So balance it, and can you also explain it? And another important point is that you have to adjust the explanation to the user. Usually only the researchers are treated as user, but there's many others, and you should actually do some user testing to test if your explanations are actually useful for the user. And another paper we discussed a couple of different explainable AI methods, and for deep learning in AI in Earth observation, this GradCam seemed to be a good candidate, and also better than the more maybe popular the saliency maps. That was it for me. Personally, I really enjoyed these meetings, and I learned a lot from reading these papers and doing it together. Maybe we should have managed expectations a bit more in the beginning. And yeah, I also had the question about how to preserve this initial curiosity and enthusiasm, because it seemed to die out a little bit in the end. And finally, I would like to thank Alison for coordinating this, because otherwise we would not have been doing this. So thanks.
Thank you, Joep. I'm quite happy if we go straight to Nova. Are you there, Nova? Can you hear us?
I am.
Hi, good.
Good morning. Good morning, everyone. My name is Nova Sharkey. I'm a statistician in the Central Statistics Office in Ireland, and I'm speaking to you today to give a brief update on the Imagery Theme Study Group. So the Imagery Theme Study Group was set up in April 2022 with participants from a number of countries. Our experience in Earth observation ranged from beginner to intermediate, and all group members wanted to improve their knowledge of both Earth observation and machine learning. The NASA Applied Remote Sensing Training Programme, or RSET, was identified as a useful resource to get us started. To accommodate the different levels of experience in the group, 2 RSET training courses were identified as jumping off points. For the beginners, there were 3 sessions on the fundamentals of remote sensing, while the intermediate group had training on using Google Earth Engine for land monitoring applications. Both sets of training were great, with recorded webinars, PDFs of the presentation slides, and transcripts of the Q&A sessions. We found the material to be clear, useful, and well presented. The fundamentals of remote sensing give a very thorough introduction to remote sensing, from the satellites used to the data produced. The Google Earth Engine training involved both recorded presentations and tutorials in how to use Google Earth Engine. And this provided hands-on experience in retrieving and analysing datasets using Google Earth Engine, and also included exercises on supervised land cover classification using JavaScript and Python. Other training undertaken by members of the group included further RSET courses on evaluating ecosystem services with remote sensing of coastal ecosystems, and land cover classification with satellite imagery, as well as self-led learning and Python scripting. Having regular meetings to update the group on progress allowed us to discuss not only the training courses, but also any issues we encountered in our attempts to work with the data. We were also able to share tips and resources and links to relevant webinars. We had a very interesting discussion on how we plan to apply our learnings in our work, and on how our different organisations use open source software and machine learning software. We all found that this type of self-study, self-capacity building group was a really positive experience. It was invaluable to have shared goals, mutually agreed deadlines, and to hear other perspectives from other organisations. And we'd highly recommend this format for anyone trying to develop new skills or improve their existing skills. And just to wrap up, the group was coordinated by Alison Bailey, and thanks for that, Alison.
Thank you very much, Nova. That was a real whirlwind, and thank you for putting this together. And also thank you so much to Joep. Okay, in the interest of time, I would like to go to our final short presentation this morning, and we actually are staying in Ireland. Now we are going to look at the AAS data and listen to Justin from CSO Ireland, and also from Gabriel Fuentes from the Norwegian School of Economics. Okay, the floor is yours.
Thank you very much. Can you hear me first up?
Yeah, we can hear you and see the slides. Thank you.
Perfect. Okay, I don't know if Gabriel's actually here at the moment because he's at a conference. So I'll just give a brief overview of. You are excellent. Okay, I'll crack on with this for a start anyway. So our project was generating polygons with AIS data for use by machine learning group. Now, why do we care about polygons? Well, essentially because it's to produce maritime polygons while also promoting capacity building for our members and future users. Because the AIS dataset has quite a steep learning curve and getting an understanding of how to access the data and fetch the data. So having been in that situation myself, it is incredibly important and useful for capacity building to be able to share code and how things can be achieved with other people who are starting out on the AIS journey. So the reason the polygons are important, because essentially all shipping happens somewhere, and that's an important feature for your spatial search. You'd be interested in things like where are waiting areas, so that would feed into things like port efficiency, where are berthing areas, what is the structure of ports, and it's also critical to reduce your search space to enable efficient fetch of your data. And also where a stopped vessel is within a polygon binding is going to be likely to be an indicator of what the sort of feature of the port is. So a problem statement. You can do this for small scale study areas reasonably efficiently. If you're a small European country like Ireland, it takes you probably a couple of hours to actually digitize your ports of interest, but that's not going to scale to a global level. And also one of the person who first proposed this was looking at sort of to try to get to deal with port polygons in the developing world where there may or may not be efficient or detailed mapping areas. So you need to have a larger pool of polygons. The World Port Index is a feature class of points, about 3,000 of them. And also we would like to look like detailed individual berths, anchorages and waiting areas. So we'd like to sort of try and use the AIS data to sort of extract these sort of features from the raw data. So we had actually quite a late start to this project. We kicked off in sort of August 2022, and the initial starting point was just a sort of using the World Port Index and creating a buffer of those to just sort of start framing the problem and introduce, what are we trying to achieve to the group? And it sort of follows out from the AIS task team. We work quite closely with them, which is the UN global platform. So in September, we had a meeting to discuss the various strengths and weaknesses of the data and what are the potential use cases for it. So in October, we sort of introduced our second version of the polygons. Now, the main difference was that it was actually a geographic buffer, because due to Latin longitude, you need a consistent size regardless of where you are in the world. And then we followed that up with a workshop review just recently that was led by Gabriel, and we'll talk about one of the use cases that comes out of that detail. So a geographic buffer creates a search space for you. Now we're using 12 nautical miles, but due to the nature of how data is actually stored within the UN global platform, they make heavy use of the H3 grid, which is developed by Uber, and that allows you to also create K-rings and sort of create a search space using from a point, just driving out a K-ring and then using that to fetch your data. And that makes it for a very efficient way of fetching data, which is a global data source, billions of records in there. And so this is our first attempt. So let's look at a use case. If we wanted to look at sort of berth identification within a port structure. So this is Port Richards in South Africa. It's a major coal exporting port. And if we just sort of start by using, the feature, the AIS data has an attribute in there that says, yes, we are berthed. Now you can see clearly that is not correct, because those ships or hexagons out in the channel are clearly not going to be berthed ships. They sort of, the master is sort of doing other things. They're going through the critical phase of entering and exiting port to probably switch the switch on the AIS and update the data. So you have this inaccuracy with anything that's created from humans or it requires human interaction. So as a second approach to try and start looking at port identification, what you can do is sort of combine sort of different attributes within your feature class and use the H3 index at a sort of much finer resolution to try and identify where the berthing areas are. Now, this was a process developed by Gabriel, which uses sort of a network technology to sort of combine the speed over ground versus is berthed, and to identify where ships are claiming to be berthed and are actually at speed zero. And that is proving to be a much more promising way of identifying berthing areas. So the challenges, as we mentioned at the top of the slide, capacity building is important as the development of algorithms, because the more people that are exposed to it will get different ideas. As part of capacity building, one of our things was to try and get some working code up on the global platform. And because that enables other people to, instead of reinventing the wheel, they can go and invent new wheels because they've got some base functions which do the generic tasks that you're going to need to do to use this data. So our approach at this stage is not used machine learning models, but we're going to be working more on that in the next few months. Now, the great benefit of this working group is we've got people from all over the world. So we've got different use cases, different ports, different indicators, and sort of different eyes on the problem, so that we hopefully will be using these different use cases to strengthen our processes and make the algorithms that we do develop more robust. Thank you. Gabriel, do you want to add anything there?
Not on my side. Very nice suggesting as usual. Yes, once again, and I like to appreciate Alison helps as well with the coordination of the group. This has been a great experience, and mostly because we have thrown some bridges among participants, and certainly even after the cooperation we had within this group, I'm pretty sure we will keep cooperating on the other projects afterwards.
Yes, I'd like to actually reiterate thank you to Alison and Kong for the help they've given us in getting this group sort of operational and working efficiently. Thank you.
Thank you both. Thank you. It was really great to hear about AIS and how that's developing and the new technology about polygons, and there's a lot more to learn for us, and I think it will continue be a very interesting area for us to develop further. So I think we had some great presentations in the last, say, half hour. We looked, of course, we started at text classification, and classification. When we started this 4 years ago, we always thought that's probably one of those areas that is probably where statistics has been very traditional for many years, but will give us a very big opportunity to start to modernize and to automate that. And I think we really see the progress. I think over the last 4 years, classification has always been like almost the top choice to develop further. It's also very easy for a country new to this to start getting engaged. So I find that very encouraging. I mean, imagery, I think we all know about imagery and the power of that. And just look at data that's available through NASA, to weather, to climate, to like agriculture, how we can measure vast areas of land and do some very quick analysis. I think it's good that we continue to look in newer and better ways, the improvement of that, and actually how can we help the statistical algorithm for that. And of course, this last one about ALS, it's for example for ONS, this is very key. We use this on a weekly basis for our faster indicators. It shows that it's very important for countries to measure what comes into your country, what goes out to your country, and then of course we're looking now to take this much further as well. So for the next, say, 8 to 10 minutes, we're going to look at some questions which will be run by Inkyu, and we will try to wrap up around 10:30. There will be a fire alarm here from our offices in the UK, so if that happens, we will go on mute, and I'll leave it with Inkyu to drive us from Geneva. So Inkyu, with that, I'd like to hand over to you for the questions. Thank you all very much.
Yeah, hopefully we can finish it so that we can properly wrap up instead of hearing alarm goes off. So the Slido Q&A is still open. So if you have a question, you can also still use the Slido. So maybe I can go from the beginning. I think this question is for Justin and Gabriel. Can you use AIs for the inland waterway, like a river or a lake or something like that?
Yes, would be the answer to that, because depending on the size of the shipping, like it's mandatory for ships over, I think it's 300 gross tons, which are involved in international trade, and all passenger vehicles, passenger ships do have AIS transponders. So there's absolutely no reason why there wouldn't be AIS data relevant to waterways, and that would particularly apply for something like the Rhine, the Danube, and sort of the major waterways of the world. So there's no reason that you wouldn't be able to use it.
Yeah, and then there's also a question about the tutorial for the land classification using satellite data. Nova, could you maybe leave the URL or the resource that you use in the Q&A as a reply?
Yeah, I think I've added a reply there. So
yep. So the previous question, actually, they were archived because the screen was getting too crowded, and I will put them all back. So the previous speakers, like Michael and Bilar and Claudia, if you have a chance after 11:30, could you check the Slido again and leave the comments directly? And so I have a many question for you about the use of imagery data. And I noticed in your slide that the CNN is almost de facto method. So do you think in imagery classification, this more like a black box model are generally well accepted? Because at least in the text classification, there is always this, oh, we cannot use a black box, other methods work just fine. Why we use a more black box model and so on? Would you consider it more like lenient in the imagery classification field?
In the what more traditional computer vision, you could derive features from the image, so you have you can summarize your image. There's layers, and you have pixel values. And you can look at the histograms or distributions or whatever and you can derive features from that. But that's a manual work, and often you ignore the spatial relationship in the image. And what you do with these CNNs is that they can they pick up these features automatically. So that's one advantage, but they also take advantage of these spatial relationships, and that's, I think, why they usually perform better.
And you also use explainers, try to make the CNN better.
Yeah, so these saliency maps is one way of trying to understand why the model comes to a certain prediction from an image. So it highlights the pixels that are activated in the network, but it has some issues as well. And yeah, so apparently these new methods they do better. So there are some techniques, but I mean, these neural networks, they're really deep and complex, and so these parameters themselves, they have no meaning. So you need other techniques to try and find out what the model is learning. Is it predicting the right thing for the right reason?
Yeah, I think this is a really big challenge for many statistical organizations, because Bilar also mentioned that if NSOs wants to use deep learning model, they need to be able to explain. And with especially like imagery data, if you have to rely on this deep learning model, then how we balance between being able to explain and being able to produce a more accurate prediction, I think that's going to be a big challenge moving forward.
Yeah, it definitely is a challenge, and of course most of these methods are actually really focused on getting high accuracy prediction performance, and not so much on the explainability. But there are there are techniques to improve it, and so it's not a reason not to use it. You just have to invest more in these techniques that help you explain these predictions.
Yeah, thank you.
It's really powerful techniques, and it would be unfortunate if you throw it away.
Yeah. So there's another question. I think maybe that's for the text classification theme group. So as far as I remember from top of my head, that the word embedding was created using a fast text, and then the top to back and the label to back actually was from the Michael from Statistics Flanders. But you can also find more information about which method were used for each presentation in the theme group report, which is available on our wiki page. So if there's no other questions, then maybe we can conclude the presentation segment of session 1 like this, and I will hand over to Eric again.
Thank you very much, thank you. Well timed. We got 1 minute here before the fire alarm comes in. So thank you first of all to all the presenters this morning, because this really makes a difference. And of course, so very much thank you to the team here in the UK for doing all the stuff in the background. And thank you very much, as always, for Inkyun and Alison for putting this work together. So this is only the first half of the day. We are back at 3 o'clock Central European time. We'll open the call at 2:45. And we continue this afternoon with the 3 following themes. We're going to hear about quality of training data. We're going to look at model retraining, and we're going to look at infrastructure. And then we will finish off with another question and answer sessions and some closing remarks from our Deputy Director, Mary. So with that, we'll see you all back at 2:45 Central European time. The slides and the questions will stay open, and look forward to see you later. Thank you very much. Hello, good afternoon. I can see numbers are increasing a lot. So thank you for those rejoining from this morning. And of course, thank you and very welcome for those that weren't able to join this morning, but very interested to hear the second part of this ML end of year seminar. So this afternoon, we're very much going to look at production. But as you just saw when you joined, you saw the slide with the first Slido question. And it's really important that as a group, of course, we understand on what are your views and what you'd like to see to happen around international collaboration in the year 2023. So of course we have some thoughts and some initial ideas which we'll share at the end, but it would be really interesting and really needed to have your views on that. So please populate that Slido question. The team in the office here will gather all that information, and also we can share some information further about that. And of course, in the same time, we also want to make sure that we understand which organization you are from and from which country you're joining us from. So I will continue with my introduction, because we have a very tight and a very packed schedule as we had last time. This afternoon, we're going to very much focus on the production sides of the machine learning group. This morning, of course, we had some very interesting like research topics. We from imagery, looking at AES data, looking at classification. And of course, we started with web scraping. This afternoon, we'll look at the quality of training data. We're going to look at model retraining, and our final presentation will be very much around infrastructure. So we will have a very similar format as we did this morning. You'll see the agenda there in front of you. So if I could have the next slide, please. Okay, so this is the code, which you've seen a few times now. So can I ask everyone to make sure that we populate the country you're from? And then I'm going to ask the team here just to share that for a sec, and we have a look at that as well. Thank you. Okay, see this again, very spread across the globe, all the way from Canada. If I look most west to Japan, most east, I see New Caledonia, Denmark, Portugal. So it's really interesting to see this really broad spread of countries and nations that are taking part of this work. And I think I can't remember the exact numbers, but I think last year we were around the 40 mark. So it will be interesting when we review this in how many countries were able to join in, and of course to participate, but very much to learn and take it back to their organization. So we'll keep this open, and if we could go back to the main presentation. Thank you, Hannah. So while we're waiting for that to be loaded, I'm going to give you a very quick recap on why did we start this, and what we actually have achieved over the last 4 years. So just give it a moment so we got the right slide up. wait one moment with us. Yeah, that's it. Thank you, Alison. So machine learning is that code we wrote, we also shared this morning, a field of study that gives computers the ability to learn without explicitly being programmed. And I think that's it's been a key threat to the work over the last 4 years. But in all this, I think the most important part is, of course, those collaborators and those people that continue to work on this to automate the system. So what we really felt when we started this 4 years ago, we approached this very much from a technology side and actually to see what is possible in machine learning. And of course, then we started to expand that. I mean, we started only with kind of 3 work packages. Then the year after, we had, I think, 6 or 7 work streams, and now even more. I mean, this year we had something like over 30 proposals coming in. If you could go to the next slide, Alison. So what do we do? Knowledge sharing, of course, it's all about, and again, there was really very much emphasized this morning around you start with little knowledge, you put a few organizations together, you find a common topic, and you start talking about that. I thought the first presentation on graph scraping was a really good example for that. All 3 NSOs were at really early stages, but they felt, okay, we got something in common here. How can we tackle that? And web scraping is probably one of those topics that we felt over the last couple of years is a very almost like an easy area to get involved and start almost like playing around with machine learning. And of course that will lead and further to research and collaboration. And of course the objective of this is what can I bring what I learn back to my own organization and actually start moving forward with start producing those statistics. So how can I actually move forward from exploration into research into production? And of course that's a big step, and that's when we started to realize that lots of other areas we had to think of. And of course then it is always there, the capacity building. How do you do that? I mean, coffee and coding sessions is something very common that we hear across many technology companies around the world, and I think this has probably been one of our very successful programs, and we often had more than 100 people just dialing in just to listen and learn from an expert in quite a short session, a couple of hours, and take away some real practical examples that they could apply then. And of course, we had the always very, I think, good up-to-date wiki from the UNECE, just to give you an option to ask with to really direct you to all the different programs. So I mentioned earlier that we started really first of all 4 years ago around the proof of concept, and then last year we started to look and introduce also very much things around like training data and quality of data. And of course this year that's really got expanded to more specific areas. I mean, AS data, I think many countries around the world, and ONS is definitely one of those that needs lots of information around shipping data coming out. So we felt there was a real good opportunity to explore that further, almost come like a specialized group. And also the infrastructure one, which we'll hear more later from Jakob from Stat Sweden's. Actually, how do you build that infrastructure ready to continue to develop the new ways of working? There's possibilities on the cloud. Some people have still work like on site, and what kind of things around security do you need to implement when you start looking at more complex data sources? So I think when we opened this up the end of last year, we asked for ideas, and I think at the top of my head something like 38 ideas coming back to us, and we were able to actually class them in these 7 groups. Thank you, Alison. So before we start looking at the first topic, I put once this question up again. So what kind of international collaboration would you like to see in 2023? So if you go into your Slido, you should see that question, and it's I emphasize a few times, but it is important for us to hear to actually what your thoughts are. So with that, next slide, Alison. Okay, so now we're going to talk. We're going to invite the sessions. So the first one will be Marco Putz from CBS. Oh, we just heard that Marco had some trouble to join us, so we're going to start with Andrea Del Monaco. So Andrea is going to talk about model retraining. So ML models, they're really built and based on patterns learned from past data, but they start to decay as they encounter new data that have not been exposed to before. So that kind of retraining process is really key for that. So failure to plan that, how do we monitor it, retrain our model, that after the deployment we can still make sure that it is very valid. So with that, I'd like to hand over to Andrea. Andrea works for the Bank of Italy, and he will share with us the findings that he has done. Thank you very much.
Thank you, Eric. I'll start sharing. Let me see. Is it fine, the presentation?
Yes, we can see your slide. Thank you. Thank you very much,
Okay,
Andrea.
perfect. So yeah, okay, thank you. Model retraining team group. I am Andrea Del Monaco. I'm working for the Bank of Italy. And before moving on, the usual disclaimers apply. So everything I will say during this presentation is on my own. That it doesn't really reflect the views and ideas of the Bank of Italy. Model retraining group. To begin with, a disclaimer is in order. In the next 20 minutes, we will briefly introduce what are the key concepts behind the issue of retraining a model, and hopefully discuss how to address them in practice. Just to be clear, the context here is that of statistical organizations, and hopefully the goal is to increase the awareness over the importance of maintaining a machine learning model, in particular retraining, so that machine learning can be integrated in the regular work of statistical organizations in a sustainable manner. Moreover, since most of the ML applications in statistical organizations currently focus on supervised learning algorithms, we will restrict ourselves to the supervised learning setting only. And we assume that the learning algorithm is offline, let's say, that is that data from the training dataset feed the model at once, a batch. Just to be clear, that this is not just my work, as this is the team group work. So I thank all the other colleagues from the group, and I invite them to jump in if they want to add something to my presentation. So model retraining. In recent years, we have witnessed growing demands of trusted information, rapidly developing and accessible technologies, numerous competitors, especially private numerous competitors. Hence, statistical organizations have been actively exploring the potential of the machine learning in their production processes. And they have been doing this in order to, for instance, automate manual tasks. We all know that human beings can hold a high level of attention only for the first 5-10 minutes. So it is really important to skip the boring steps of a process so that the humans can focus on what really matters. To substitute classical statistical methods with modern ones, so replacing probably an econometric model with some other machine learning model. And finally, why not to produce new statistics that they couldn't really produce before. Anyway, we should be cautious in applying machine learning. There might be not happily ever after all. Why? Well, the degradation of a machine learning model affects the quality of the statistical production that is based on the model predictions. And so as time passes, stakeholders may lose their trust in the support given by machine learning models if such models are not properly maintained. Hence, models should be continuously monitored and in some cases retrained with the purpose of maintaining their performance at the bar. However, we acknowledge that machine learning is a relatively new area of work in statistical organizations. Hence, sometimes we don't really pay so much attention in what happens in production And the lack of experience with machine learning models in production may result in low awareness and understanding of the importance of model maintenance. A proper machine learning governance is necessary for the model to be accepted by end users and to be supported by the IT department. In a sense, model maintenance should be considered as a part of the quality management process needed for the application of machine learning. Indeed, if in one hand, the performance of the machine learning model might be a necessary condition for it to be deployed, on the other hand, it is by no means a sufficient condition. If we miss such governance, then a vicious circle is created. Namely, the lack of experience with machine learning production can lead to lack of consideration of machine learning maintenance, which in turn cause lack of accessibility for acceptability of machine learning models by stakeholders. And again, in turn, it causes the lack of experience with machine learning production and so on. So a proper machine learning governance plan can hopefully break such a cycle, for instance, by retraining our model if we have noticed a degradation of our model performance. But why degradation happens? Machine learning models are built over a training dataset under the assumption that patterns that we found therein are valid in making future prediction as new data come in. It might happen that machine learning models, even those trained with the highest quality data and carefully engineered, start to decay over time. The model decay or drift can occur for various reasons. For instance, because the underlying phenomenon has changed, or probably because some systematic or structural change occurred in data. They have been introduced over time. Think, for instance, if the methodology of a survey has changed over time. And let's think also for a second about new types of jobs and products that just entered the job market. Our model might end up dealing with new words in job descriptions, either in labor force service or perhaps in web pages that we are going to web scrape. Anyway, the model may potentially be exposed to patterns it was not trained on, and this is something that we should take care of. But formally, what is a drift? Generally speaking, a drift refers to a change in an entity with respect to a baseline. Such an entity can be the model itself, in which case by drift, we mean a situation where the performance of the model at hand has changed, or the data set. That is, the data the model was training on has changed. More specifically, let X be a set of features or covariates, and let Y be a target variable. Assume that they have a joint distribution Px and Y, and that there exists a mapping F such that Y is a function of the covariate X. In our setting, which I recall is a supervised offline context, we also have a training dataset S of covariate and target tuples. Then the aim of a machine learning model is to predict the value of the target variable given the values of the covariates. Namely, the aim is to obtain a prediction model that we made a note abusing the notation as I did here with f hat of S. For example, in a classification problem where we might have that the target variable Y takes any of C1, CK, any of the classes C1 and CK, f hat of S assigns the category that has the highest conditional probability of Y being equal to a class given the covariance X. However, in production, we have new data coming in. Let's say the data set S star of new values X of the covariates and the predicted targets Y hat of Y hat. And it might happen that our performance metrics starts to lose momentum. That is the estimated conditional probability learned from data S, from the training data S. So P hat of S of Y given X does not hold anymore, which means that the model has degraded, has drifted. What kind of drift are we talking about here? There are two types of drift. A model drift, there is the model drift, that is a change of the overall performance of the model, which means that the estimated probability doesn't no longer hold. For instance, the model was developed and trained 2 years ago with a certain level of accuracy, and now this accuracy is far below a certain acceptance level. And there is the concept drift. That is the joint probability of X and Y with respect to the training data set S is different from the joint probability of X and Y of the new data set S star. It is worth noticing that in view of the bias theorem, the concept drift may actually be broken down in target drift, that is a change in the probability of Y. For instance, there are more computer-related jobs in recent service. It may be broken down in feature drift, so the probability of X of the covariates has changed. And for instance, more computer-related jobs in recent service, and posterior drift. So the probability, the conditional probability of Y given X. For instance, the word some word that at that time was used to mean something, now means something else. For instance, we ended up with this example of the word PC that once indicated police constable and now more frequently is a personal computer. It is important to note that the occurrence of any of such drifts does not necessarily lead to model drift. For example, if the distribution of X of a feature X changes in a way that the model is still valid, the model performance would not decrease. Here we can see the block, the upper right block. So probably is I can do this guy here. So the distribution of X has changed, but the model is still good at predicting the target. How to detect a drift anyway? Well, there are two main approaches that can be considered. A performance-based approach and a data distribution-based approach. What are these methods all about? Well, the idea behind the performance-based approach is that if a drift occurred, for instance, some changes are introduced in the new data that are not being captured by the model, then the model will not perform as good as it was to. And therefore, this approach monitors the performing metrics. And to do that, it requires a collection of true values of target variables in order to assess the error of the predicted values. Among the many available methods, we may list the drift detection method, the statistical test of equal proportional detection, STEP, and the adapting windowing method, and others. The data distribution-based approach, on the other hand, compares the distribution of training data used for the development of the model with that one of new data. So, for instance, the distribution of features can be checked by looking at contingency tables, histograms with KDE, and everything that we usually do in these cases. Distribution can also be, the distance between two distributions can also be assessed by appealing to the callback library divergence, Salinger distance, and so on. Which approach should be adopted? Well, it is not really straightforward to answer to such a question, but a couple of things can be taken into consideration. So, the performance-based approach addresses directly the data aggregation of the model. which, by the way, is the ultimate purpose of monitoring, and perhaps it might be easier to implement for production. Whereas for the data distribution-based approach, we acknowledge that it can be trickier to set a corporate-wide monitoring system, essentially because such an approach is tightly bound to the data type, to the data preparation methods, and so on. Nevertheless, monitoring what happens to our covariates, that is the feature drift, is at least from a chronological point of view, the first thing that we can actually do in practice to raise a flag on potential drift. And by the way, checking what's going on with the features might also be crucial to gain the trust of stakeholders, since they are supposed to have a certain domain knowledge over the data. So now we have methods to detect the drift, we have detected the drift, and what are the next steps? Should we go ahead with your training? Why should? Well, the decision to train the model or not should not be taken for granted. In an ideal world, we should always retrain our model when a drift has been detected. However, we are not living in an ideal world. So in practice, what to do? In practice, a cost-benefits analysis should be carried out. Why? Well, probably because the impact of the model drift can vary. Not probably, okay. The impact of the model drift can vary from application to application. So probably, for instance, the impact of the model drift can vary depending on the application and the use cases. If the model is used to support a human expert in whatever internal process, and it is not really crucial to keep the performances up at the bar, maybe we can avoid to retain the model if the drift has not that has not an impact that disrupt for the process itself. On the other hand, if the model is deployed to produce statistics that are going to be published, then the drop of performance of the model performance affects the credibility of the statistics, and a kind of reputational risk should be contained. So in this case, probably the model should be retrained. And the other costs that we have to take into consideration are human resources. Human resources are requested to retrain a model, especially when the automation is not possible or feasible, or probably because the drift is really disrupting with respect to the baseline. Indeed, retraining might require the involvement of data science, ML experts, IT guys, and so on. For instance, we might need people to collect new data. We need some people to check the retraining process and so on. So statistical organizations have to allocate people on new processes, and we all know that these skills are rather limited in these days in statistical organizations. So it might turn out that statistical organizations have to move persons from one department to another, and so on. This may cause a break in operational in the operations of the statistical organizations. For sure, anyway, the research, the development, the deploy, and the maintenance of machine learning models requires a multidisciplinary collaboration. The main expertise involved in the process of development and maintenance can be grouped into 4 categories. The data science expertise to develop the model, the business or domain knowledge, let's say, to provide deep understanding of data and guiding the development of the model, statistical expertise to design, for instance, quality checks, and finally, clearly, IT expert, ICT experts, to build a platform that will host the model, to develop services necessary for monitoring, and so on. Clearly, the involvement of such expertise changes from a step to another along the ML pipeline, along the machine learning model pipeline. And so it might be the case that in some steps, data scientists are more involved than IT experts, or IT experts are more involved than business guys, and so on. Such different levels of involvement should be acknowledged in statistical organizations, and also from the organizational point of view. So, okay, the above being said, I am done, and I thank you for the attention.
Thank you very much, Andrea. I think it's fascinating just to see what is included when you start looking at model training and all the different angles you have to think of, and I think you really outlined that very clearly there. So we have a bit of a change of order, but in the background we'll be able to get connection now with Marco. So Marco Putz works for CBS in the Netherlands, and Marco is going to share with us what we and continue the work he's been doing over this year, and talk very much around the quality of training data. So with that, I'll like to hand over to Marco, and then after that we'll have some time for questions for the first two sessions. Marco, it's all yours.
Hi. So this presentation will be about the quality of training data, and I think it's. I found out during this year that it is actually a very hard subject to talk about. I hope you all hear me. So. Okay.
We can hear you clearly. Yeah. We can hear you clearly, Marco.
Okay,
thank
perfect. You. So I always have Teams problems. So, so it is always hard to talk about the quality of training data because of the fact that it really touches to the working field of a statistician within official statistics, methodologist, survey methodologist, and the area of machine learning, of data science, and it's actually at that point where terminology is not the same, where people don't understand that we are talking about different populations and stuff like that. So in this presentation, I would like to give you a short insight in that world. So now I have to get to my next slide. Okay, here it is. So what are we talking about? We are talking about a finite population. It's the blue one. Oh, wait. It's the blue one over here, which is indicated with an X, and that population we want to say something about. We want to make a certain statistics about the population. For instance, we want to count the number of companies which have a certain property or something else. So we start with population. What you normally do within machine learning is you say, okay, I get a sample, some sample, of some sort. Normally it is a non-probability sample, and I pick that out of the population, and I'm going to train split up part training, validation, and test data, and I'm going to train a model based on that. And at the end, statisticians want to use this model that is actually trained to say something about the population itself, so about the blue thing. So that is something where a lot of survey methodologists start to think, something is wrong here. But why is it wrong? And it is wrong because of the fact that you are actually not building a model about the complete population, or about a model that is representative for the complete population, but you are actually only building a model which is representative for the small area here. So what you actually would like to do is have a probability sample over here, and actually train a model on the probability sample, and hope that that the model is actually generalizable to the complete population. So that's what the field is about. It's a discussion about how do we form a training set. What should we do to guard the quality of the training set, and what are these quality criteria that we are talking about? How are they going to affect finally the machine learning model that we trained? So also the terms are different, whereas a data scientist at the moment that we look at classification talks about the confusion matrix and has performance indicators on that, and does things like k-fold cross-validation. The survey statistician is talking about finite populations, about sampling errors and bias estimations. So the worlds are a little bit different from each other, and when you are going to talk about creating a training set, the quality of training data, you're talking about the problem between these two. And why is it important? A lot of these studies are done on a found data set, non-probability sample, maybe sometimes a probability sample, but just a sample. And at the end, we would like to generalize the study, the model that the study actually gives us, to say something about real life, about ground truth. We want to say something about the population and not just about how well the sample that we used is actually saying something about the world. Within the field where I come from, psychology, this is called the difference between internal and external validity. So normally you design an experiment to say something about the behavior of people. And this experiment, you don't do that on a complete population. No, you only do that on a very small set of people. Sometimes only students, psychology students at the moment that you work at a university. And at the end, you want to say something about a certain system of the human, or you want to say something about human behavior in general. So and that's where the term external validity comes from in psychology, and I like that term. I like it because of the fact that it actually says, okay, we now have this internally created model, and we want to generalize it to real life. We want to have to use it in the external world. So that's the reason why I talk about it. So after a lot of discussions within our group and a lot of moving around, we finally decided to look at the total survey error model because of this. Because actually, the total survey error model is about populations, the finite populations we are talking about. It's about the part of the data that we can look at, the way we sample it, the way we measure it, the way we create a construct to deal with it and to deal with the data, to deal with to see what relationships are in the data. And normally we do that by designing a survey, and about measurements. So that's the reason why we actually came up with and to start with a sort of spoiler about the work. So in training, you are going to create a training set which can be from which a quality can actually be measured using the total survey error model. But at the end, you would like to make a prediction. So the model is actually in two stages. One, the training stage, where you are creating the model, and then the prediction phase, where you are going to use the model to make predictions. And what's actually quite interesting about it is that during the prediction, you actually only have that prediction error over here. And the prediction error actually comes from 4 different errors in the total survey error map model: the validity of the model, the measurement error, the coverage error, and the sampling error. So when we talk about validity, then we are talking about the how valid the model is. And normally when you are using a very data-driven approach and creating within data science a model, you actually don't think that much about the relationship between variables, the relationship between your independent variables with your dependent variable. You don't think that much about constructs, but actually at the moment that you select your data and you are going to train your model, you are implicitly you are actually using a construct, the construct about what the model is actually going to deal with, and the different variables that you have in your data set. So there is something like a construct validity, but it is very implicit and not explicit. And at the moment that you train the model using this data-driven approach, you will have a lot of problem in proving the construct validity of your model at the end, which actually makes sure that you cannot say that much about the external validity of your model. So that's one of the problems. And what you could do is actually use explainable AI, where you look at the pre-explainability, where you just say, okay, I'm going to think about what is actually going on in real life, to find a relationship between variables that you are using for the training. So not just take the data, throw it through your machine and see what comes out, but start thinking about the pre-explainability of your model. So then the measurement error comes from different sources. First of all, it comes from annotation. So when you are using manually annotated data, a lot of errors are actually introduced during the annotation process. People don't annotate in the same way, so you will see a difference between different people that do the annotation. And there are some techniques actually to see if there is if the process is going well in the form of disagreement metrics, so that you actually look if all the annotators, when you are going to give a certain case to the different annotators, how far do they give the same answer to the same case? So that's one of the things. Another part of measurement error that can exist is that maybe the target variable that you actually want to have annotated is not really clear for human beings, but also maybe not for machines, visible in the features. So at the moment that you have such a situation, it is better to have another source which is available from which you can annotate the data better than just stick with the source. An example of this is the ground truth and remote sensing data. When you are, for instance, looking at what kind of crops are in certain fields, then annotating the data is hard at the moment that you look at the satellite images and are going to annotate from them. It is better to actually go to the field and see what crops are growing there, and in that case you can actually get a much better annotation. So we don't have response or edited data at the end. Well, we do have a response, but we don't have edited dating. So processing errors we don't have at the moment that we do our thing with training sets. But we have a target population. For instance, suppose I have as a target population all the companies in a certain country. And I have a certain sampling frame. And the sampling frame could be maybe all websites of the companies in that country. Then that sampling frame can be different from the target population. There can be an overcoverage or an undercoverage. That can lead to an error. So second, at the moment that we sample, we can have a sampling error because maybe the sample is too small, or maybe it is not a complete random sample. But suppose the sample is too small, then actually the error will actually be bigger. And all these errors that I discussed now, the validity, the measurement error, the coverage error, and the sampling error, actually will, at the moment that I'm going to use the model for prediction, will actually end up in that prediction error, which is over there. And there is something strange about that prediction error. And for that, we have to talk about accuracy and precision. So precision is how close the dots are all together, and the precision is about how close the dots are together, and the accuracy is actually about how well are the dots around the target point that you have. So we also call this a low accuracy. We actually also call a bias over here. So that's the terms that I'm going to use here. And what you actually see, and that's the strange thing, and that was really hard to discuss this point, is that accuracy and precision, so low accuracy and low precision in the training set will actually lead to a model which is not that accurate in the prediction phase. And how does that come? Suppose I have here this situation with a high accuracy and low precision. Then you see that they are also centered around the middle. But suppose that based on a sample, a training set, I am going to have a model which ends up here. Then all the predictions that I will do will have that error in here based on the fact that the point is not really in the center. So the point is that all the predictions of the model will have a bias in there. So that's one of the things. Another thing we talked about during the process is actually that there is a difference between the infinite and the finite population. The infinite population is something like a generating process. Suppose you are using machine learning, computer vision, to indicate if a certain crop has a good quality before it goes to the shop. Then you can see that the production of the crops. You can see that as an infinite population problem. There are always new crops produced, and you can see the fact that you have a nice crop or a bad crop. You can see that as a random process. So and that's actually where a lot of these machine learning algorithms that we use are actually coming from. So in that case, we can exchange different crops because it is a random process, and we just have the infinite population. And a sample is a realization of a random variable. At the moment that we do look at the finite population, then the different items are not exchangeable. And the sample is a set theory concept. So, and the difference between the two is that actually the models are formed in a different way, should be formed in a different way. And a lot of the machine learning models are actually made to talk about that infinite population. That's actually something David Salgado could talk about a very long time, and it's very interesting, but it is very important to realize that you are actually creating models which are talking about, which should talk about that non-exchangeable part. We are doing, in official statistics, we are counting. We are trying to count the number of companies that, the number of people that, and with the machine learning models, you are actually talking about probabilities. So that's one of the things. So then I come to the conclusion, and I hope I didn't take too much time. So survey methodology is important when dealing with sampling as training sets, and I think that is really the main conclusion of our work at this project. We saw during the presentation that the use of concepts that we use within survey methodology, that the total survey error model is actually really suitable for designing training sets and at the end training a model. The most errors in the sample used as a training set result in a bias, which is really a freaky thing about this this kind of work. And in case of human annotation, we should monitor the annotation process. And finally, what are we modeling? Are we modeling an infinite or a finite population? So with this, I would like to conclude my presentation. Thank you very much.
Thank you very much, Marco. And thank you also very much to Andrea for starting this afternoon and being flexible. So when we take a few minutes now, about 10 minutes, to look into the questions. And can I remind everyone to really put those questions, Slidos for the presenters, for Marco and for Andrea, and also, of course, the question we got outstanding for 2023. But if you just look at the two parts that first Andrea shared about the model retraining and about the continuously monitoring what is happening at the stage, and this will be an ongoing process. He also talked very much about ML governments, and I think that's a key part. We're finding out that governments like framework we need to adapt to, and we start moving to the official statistics. And of course, he explained very well all the different variants around drift and model drift and concept drift. So I think it was a real good piece of work that the guys have put together over this year, and it's something very much also in ONS we like to benefit from. And of course, then we had Marco's presentation on model retraining, and as he said rightly in the opening, it's very much probably you scratch your head in the beginning. Where do you start around this? I mean, he mentioned around representativity and ideal versus real world. I mean, how do you tackle that? He also mentions that the data-driven approach, which we hear very often in today's society, and of course, then explainable AI. How does it make sense to people, and how do we explain what we're doing in this sometimes very complex ML world? So with that, I'd like to hand over to Inkyun. Inkyun is going to run us the questions, and then we'll finish off with our final presentation. Inkyun, it's all yours.
Thank you, Eric, and thank you, Marco and Andrea, for this interesting presentation. Again, I think these two issues are really underexplored, or if anything, like under-discussed in the community. In the community. So thank you very much for bringing attention to these important issues. So I'm sharing my screen right now with the questions, and yeah, I see there are new questions coming in. So maybe we can start from the questions related to the first presentation. So the first question is, can we just retraining regularly, like annually or quarterly?
Yeah, that's hopeful. Hopefully, that should be a best practice, actually, to retraining from time to time. It also depends on the frequency that new data is coming in. It depends on, I mean, if you have data every day, probably I will short this period, but yeah, that definitely is a good practice. The problem with retraining regularly also, as I was saying during the presentation, is a matter of cost benefits. Okay, so for instance, do we have a team dedicated to this task? Do we need some other financial resources to do that? Do we have an IT platform that is able to support us in doing that? So there are actually many issues behind this simple question.
Yeah, that's true. That it's not. If it was simple, that we wouldn't have this kind of a big discussion yet. So the next question is also related to retraining. Maybe it's more of a clarification question. Isn't a key difference between the performance-based approach and the data distribution-based approach is that the former requires the true value and the later does not?
The data distribution-based approach is referring to the distribution of features, right? So you are talking about the covariates, whereas when you are talking about performance, then you are checking true values as the targets. So you are checking what happens with respect to the targets.
Yeah.
Does this answer the question?
I am so. Yeah. So if you need a more clarification or more detail, you can also type directly in the chat. And then we can move to the next one, still related to the retraining presentation. If the model correctly understand the relationship between the X and Y, how problematic is a change in the either X or Y? Is a change in the feature distribution not a poor measure of a model drift?
I guess it depends, and I think there are many overlaps in here with the moderative data quality team group. It depends on the representativity of the data you train the model on. So, I mean, I wouldn't know how to answer. I mean, probably Marco can help me in answering this question. It's really a matter of representativity from a statistical point of view. So probably. For instance, you had in a balanced data set, and now probably something else is happening. It's really a matter of sampling biases and so on, I guess. But Marco can help me.
Yeah, actually, that is a nice bridge, because next question is related to the second presentation from Marco. And Marco, feel free to also answer on this question. But maybe I will just read this one first. And model validity applies for both a statistical method, like a regression model, and as well as a machine learning model. Would you say that the issue, this model validity issue, is more serious for more data-intensive approaches like machine learning?
Yes, I love this question. So we had within our office, we have a lot of discussions about it lately because we created some data-intensive models. And every time you have a data-intensive model, a data-intensive approach, you see that finally you will have problems to actually say something about your validity of the model. And the reason is quite simple. Normally, you start off with a model which is actually based on it has a theoretic basis, and you define how your construct is actually formed, and you create and you start a model from that construct. So at the end, you have a model, and the model has some scientific basis, has some theoretical basis, and validation is actually much easier at that moment, because you just can say, I'm going to take some time series which are related to the subject, and I see how they are related. And actually, you are very close to having a very valid model at that moment. So at the moment that your p-axis not changing, so that's a small bridge to that point again. So I think, and I think most of my colleagues actually agree with me within Statistics Netherlands, that data-intensive approaches actually have more serious issues with something like model validity. Yes, so there may be something about the p-axis and the p-y's. Actually, the p-axis. I think that a lot of models that we use, and it is actually also in the report right now, actually suffer from the fact that we also, because of the selection of the features that we use during training, actually suffer a lot on the forming of the p-axis. So actually, I like to look at classification models. At the moment that you look at a classification model, it is actually trained on a classification model can actually be seen as a Bayesian machine, which says what is the probability of a certain class C given the feature set X. And when you look at it in a Bayesian way, you actually see that the distributions of the axis in the different for the different classes actually tell you something about how high that probability is. So in a pure Bayesian form, when you look at that way at machine learning, at classification models, then you see that at the moment that I have a feature that is actually showing some spurious correlation with your target variable, it will actually deliver a lot of this disturbance. So at the moment that you are going to use it during production to do some predictions, you will see that model drift actually appears very quickly. And I think that's something Andrea would actually agree with me, and that's actually the main problem of the p-axis, that should be as stable as possible, and why the p-axis actually a good measure of one sort of model drift. So I think that should be the answer from the quality of training data point of view. So yes, and I hope I answered both questions.
Yeah, thank you for also sharing your insights on this issue from the model quality of training data team side. And I see now we are top of the hour. Maybe Marco, can I ask you to reply these last questions through the slide directly? Because I think we need to move to the next presentation now.
Perfect.
Yep. Thank you. So now hand over to Eric.
Thank you very much, Inkyun, for hosting that. Yes, there's lots of questions which we will, of course, capture, and we will try to find a suitable answer for as well. So with that, we're going to move now to our final presentation from the infrastructure theme group, which was hosted and chaired by Jakob Engdahl from Statistics Sweden. And I think what we learned as well is that machine learning, building machine learning integrating capability requires more than just the technology. And I think we already identified that. And after looking at this, we need to start moving it forward from the experimentation stage. So how do we scale that? How do we build the right infrastructure? And how we make sure we have the right environment in place? So a small group of us got together on that. So I'd like to hand over to Jakob, and who's going to share the findings of this year. Thank you, Jakob.
Thank you. So let me know if you can see my slides.
Yeah, we can see your slide. Thank you.
Yeah, great. Okay, thank you so much for letting us present a short presentation from our group. We've had a number of interesting discussions in this group. I think one of the things we realized is that it might have been the wrong name from our group. In some ways, it tends to be the sort of everything but the actual machine learning use case group. And this is an indication that we see a lot of examples in this session and previously on good use cases for machine learning in official statistics. And one of the elements is that cost-benefit analysis that Andrea mentioned before, that there's still sort of a tricky thing to get machine learning projects going. And once they get going, it might be difficult to take them all the way to production. So that was sort of a focus. Well, what can we do in this group to highlight some of the reoccurring themes of things that need to be in place in order to do machine learning more on a regular basis. One of the sort of images that you might have seen me present before, highlighting what Eric just said, is that you tend to see this data being pushed into machine learning code, and you see a solution on the other end. And I know in this case I'm preaching to the choir, because we've seen the complexity that doing machine learning for real products, real production actually means. But one of the elements where we think that we as a community can collaborate further is to see that this machine learning code needs to exist in a context which simplifies each machine learning initiatives, which makes it easy to run this type of initiatives on a broader scale, to scale up your organization's capacity for doing machine learning. And some of these things are quite normal in statistical production before machine learning. So like data collection, data verification, we might use different word for it, but we do see elements of this since we are data intensive organizations. But I do think that the machine learning community have a tremendous development within the community, and we can benefit from looking into how these different types of components can be sort of highlighted, and how we can relate them to the existing processes and systems we have. So this is a somewhat old paper by now. 2015, Google sort of realized that you need to have certain things around your machine learning code to do that as regular production thing. And then we sort of had the focus on the technology platform, but in the discussion, we tend to, in a way, zoom out. And I realized that the whole session today has been sort of not backwards, but we've begun by looking at good implementations of machine learning, and then took a step back and tried to look at some of the reoccurring themes here and how we work on quality and retraining. And we maybe done the same thing in our group. We started out looking at the technology platforms, but we realized that some of these things require us to relate the technology, the new components, to other things within our organizations, like regular business processes, like governance structures, organization understanding and security, competence, ethics, and legal. So there's a bunch of things that relates to machine learning initiatives. And the more you have and the more ready you are on these surrounding initiatives, the better you will be at performing machine learning initiatives. So in a way, when we sort of dive deep into the technology platform, when we try to figure out how can we together make progress in this area, I think we sort of saw that it relates to the maturity of each organization. So you do have that initial state where you have a good proof of concept, you have a few people who are becoming experts in machine learning. But as you move along and try to spread the use cases of machine learning and get more people involved, you need to think about how you make it as easy as possible, so the overhead cost of doing machine learning compared to other initiatives isn't as high as it has been in the beginning. And we would like to all, I think, be in the mature area in this diagram, but I think, at least for us, we are still sort of scaling our machine learning initiative. So it's definitely relevant topics for at least our organizations in our group, but I think this applies to most of our organizations. So in this case, we've sort of seen that we've looked at the machine learning use cases where we make implementation of machine learning, and we try to have an iterative approach to see what were the problems, what have been good solutions, what have made less success, what have been less successful ways of operating machine learning, and try to move that experience to some sort of building and scaling the capacity, which in turn will, of course, make it easier to implement new and improved solutions for machine learning. So we, in our group, had these topics that we felt that these are recurring themes for machine learning. And some of these relates more to ML ops. I think we've realized that a lot of the discussion we've had are more related to ML ops, like machine learning operations. And this is a type of element, the type of theme inspired by DevOps and DevSecOps and all those things from the development community. But I think we see that architecture, technology, infrastructure, these are recurring themes. When we stop training models on our local laptops, when we stop installing packages locally or manually, what are the ways we can organize architecture, technology, and infrastructure so it's easier to get going with machine learning initiatives? That also sort of left us into a direction of who is involved in this, who makes sure that we do have the right technology set, that we are prepared, that we have the right data flows between wherever data is being created and machine learning initiatives where it's necessary to get that data. We also have the connection between statistical production processes and machine learning processes. And this is maybe where we began our discussion in this group. We took a quite new model, which tried to create this sort of stereotype of machine learning initiatives, and you can see that on the right side here. So Inkium I think you wrote this in a paper at some point, and we looked at this and we provided some feedback, and you can see a sort of retraining loop at the end there. And the question we began with was, how do these processes relate? So we do have a statistical production according to the GSPPM on the left side, and there is a sort of a data flow, a continuous data flow from collecting, processing, analyzing, and disseminating data on the left side in the GSPPM model. And now we need that data or additional data to flow into the machine learning projects and processes. And then we do retraining. That new data piles need to be as automated as possible, and we need the retrained models, the models and retrained models to be deployed into production. So there's a sort of a continuous integration between these two worlds. And that is sort of where we began to look at what are the similarities and how, in the beginning, do we do simple proof of concept projects, and then later on, how do we do training and retraining as a regular production, not a statistical production, but rather maybe model production, an ML production, and models more efficient. We found a paper that we got quite a bit of inspiration from. It was a ML Ops paper trying to describe the components necessary for doing ML Ops, and not only the components, but also why we need these components. So you can see the principles on the left bottom corner here, and why is it important to have these things. Now, coming from an organization that already does a lot of data intensive work in regular production, some of the topics that we sort of found were potential overlap with existing components, like for instance, source code repositories. We might have that already. Do we need separate source code repositories for machine learning, or do we mean the same thing? Do we need the same thing? How do we integrate with regular production, like serving technologies, model serving technologies? We've looked at some of our organizations are more treating the machine learning initiatives as innovation, running them in an innovation environment, whereas some are more closely related to production when you do this on a regular basis. So multiple environments where these components can exist and coexist with other components. Then we also seen that there's a lot of open source within this, a lot of use of open source within these groups. So there's been a lot of discussion about the possibilities of collaboration, and we've already seen a couple of collaboration where we also share the solutions for these components and the platforms that we can build. And lastly, the topic of these being quite modern technologies, there tends to be a possibility of running them both in a cloud environment and on an on-prem solution. And if we look at that collaboration around platforms for machine learning, I mentioned there's a high degree of open source components, open source platforms. And we've seen that a couple of us are creating reusable platforms for doing not only that specific machine learning project, but rather looking towards MLOps and integrating these processes as part of regular production. Some of these are already being shared between organizations, and we see that since they I think all use open source as the foundation, we also see that there are a lot of similarities between these shared solutions. So that might be an indication that this is a topic to follow along after this project to see how can we increase further collaboration within these different platforms. We also see that a lot of us are building these platforms on so-called container platforms, and that is in parallel being developed by a lot of organizations, the capacity to run things in containers. We also have that topic of some of these platforms do solve or support general innovation. Some are more focused on production. Some are only focused on machine learning. So there might be some differences in them as well. And one of the things that we all try to deliver on is, so I've stolen this image as well from a Netflix paper, but I adopted it to statisticians. So statisticians tend to focus more on the top elements in this image, the data, the production logic, the metadata, while as IT tend to care more about compute resources and automating production, security, and these type of things. So all these platforms mentioned in the previous image, they try to package the lower levels of these, so you shouldn't be, as a data scientist, responsible for solving how you do compute resources or scaling or scheduling of containers, etc. So this is a new element which sort of intensifies the necessity of collaboration between statisticians, data scientists, subject field, IT, all of these cross-functional groups. And on that track, we also see that building competence, even though we didn't dive deep into this, we see that this is a prerequisite to do MLOps, where you in the beginning probably have awareness of that there's such a thing as machine learning. You might have someone who's already knowledgeable about machine learning, but as you want your capacity for doing machine learning to increase, you see that you go from the individual level to the organizational level. So part of that transition to a more mature machine learning capacity is to ensure that the organizational capacity is there. And that led us into the discussion about the organizational structure. How do we organize our different teams? We see hubs and spoke solutions, center of excellence solutions, communities of practices, informal networks. So very different ways of organizing machine learning within organizations. But they do also differ in what they deliver. Some focus more on producing, ready machine learning solutions, ready build models. Some deliver platforms, some deliver skills so that the business side can increase their knowledge here. So this is also an area where you see that we already identified that we do this in different ways, and there might be a good way to further collaborate on this sort of the best practices of building organizational capacity. And lastly, the roles and capabilities. We've already mentioned some of these roles today, but we see that there is as the subject field of machine learning becomes more mature, we also see new type of roles emerging. So like a data engineer was probably something that I hadn't heard before machine learning became a reality. And the topic, of course, for us is how do these relate to other roles like laborers and statisticians and regular IT and these type of things. We also see that there's a difficulty to recruit and keep these expert roles, and part of it might be that the MLOps capacity, the capacity in the organization, isn't quite there to make machine learning a more smooth process within our organization. So this is a further topic that requires more focus going ahead. And that was it. I would like to also thank Alison and Inkyung. You've been really great in pushing the discussion forward, and also making sure that we start to produce material and see if this can lead into a good report at the end. Thank you.
Thank you very much, Jakob. I think a very different but very inspiring presentation. I think that slide you put up there around like a different focus, and I think that's where we as different groups are coming better together. I think is really interesting what we're learning also from an ONS perspective. Is that building that gap between that research part and that capability part, and that needs to become closer. So now we have a few minutes just to look at some questions for Jakob, and then also Inkyun will share a little bit about the lessons learned before we start coming to a close of this afternoon. So Inkyun, I'll hand over to you. You possibly still muted, Inkyun.
Yes.
Yeah.
Yes.
Thank you.
Thank you. So I think the questions on the screen is more straightforward. Maybe you can share the timeline where we can see your paper published, the paper of the theme group.
Yeah, so I just sent you a link to the MLOps paper. That's not the paper we wrote. That's someone very skilled outside our group. But we'll definitely, we have, I think the issue that we have the text ready, but it's not a coherent mass of text at the moment. So I think we'll need a couple of days or maybe even a week or two before we can see a complete report. But we have the structure in this to describe the reoccurring themes that I mentioned. And I'm not sure if I can mention all at the top of my head, but it's organizational skill sets, it's infrastructure and architecture. It's that serving technologies or pattern for serving models. And I might have missed some of the topics there. Oh, something, yeah, we also talk about the machine learning maturity model and try to sort of contextualize what we're talking about. You shouldn't, as your organization, you should probably not begin by implementing a full MLOps project before you run a couple of proof of concept or machine learning initiatives, because that would be sort of a high risk investment. So, but it's our paper, our report is aimed towards our community rather than your generic organization looking towards machine learning. I think that's the difference.
Yeah. So all the theme group papers under the machine learning group 2022 will be published in this wiki page. So maybe you can check in 1 or 2 weeks so that you see the final report. So maybe I ask some question that I also had in mind for a long time. So like if you hear all this topic around like building infrastructure or building environment, I think maybe many people feel this is a too big problem to grasp around. And then maybe organization could feel also lost to where to start. So is there any low-hanging fruits or some concrete actions that you did in Statistics Sweden, or you saw, okay, this is a good concrete low-hanging fruits toward that there's other organizations who are in the beginning of the journey to make toward this goal?
I think we've seen all group members invest in some sort of skill set building. I think that's a good way to start. What I think that beyond sort of the R and Python and the PyTorch and all the frameworks for machine learning, it might be good to also have a broad communication investment. So like top level management and a broad sort of more subject field statistician oriented training. I think that might be good to spread the word or spread the interest of machine learning. Whole initiatives. So that might be a good way to create a sort of interest and a pull for further development into this. So more parts of your organizations are involved. In our case, I think it's also that container environment that tends to be very important. So yeah, I think we all need our IT departments to deliver
I think your connection is starting to fail a bit, Jakob.
Oh, sorry.
Yeah.
Yeah, I think it's the Skype. Sorry, it's the Teams thing. I do have a problem every now and then with it.
So you're talking about the container?
Yeah. So just to have a production ready level capacity for running containers, I think that is a very good start on something.
Yeah, I think I can definitely relate to especially the first one. I think during the break, there was someone who posted a question on the Slido that he or she is trying to use machine learning, and they're at odds with the methodologist in terms of quality. So I think increasing the general understanding about the machine learning and the values and the impact, I think that will be definitely very concrete first step. So I see on the slide that there's no further question on this topic. So maybe I think we can now conclude the presentation part of this session. And thank you, Jacob, again for this presentation.
Yeah, thank you.
And also leading the thing group.
Yeah.
So
Thank you. No, that would be great. Great, thank you. And if you may be just happy to take us for a minute or two through the lessons learned, and then I will do some suggestions around the plans for next year.
Yeah, so I will try to briefly recap some of the key lessons learned during this year from different theme groups that we've seen from the morning and from the afternoon session. So I think first thing is definitely that this machine learning field is fast changing. So this fast pace in this field also implies that the statistical organization should continuously invest in expanding the knowledge base, and as well as supporting their staff in acquiring the new skills so that they are up to date. And we saw many use cases of machine learning. Some of them are actually outside the usual production area. So statistical organizations also should continue exploring this different application area to reap its potential, while also deepening the knowledge and experiences in the area that we already know that machine learning can be effective. And this afternoon, we also saw how the expertise in quality that statistical organizations already have, like in theory, in practice, procedures, and experts that can also be used to analyze the quality issues around the machine learning, which is one of the biggest challenges around the machine learning. But I think putting the machine learning in production still remains quite difficult. And I think it's the most challenging aspect in using machine learning for the statistical organizations. So for statistical organization to use machine learning for a long term and then also in an effective way, I think establishing this environment, including culture, skill, data management, or in IT infrastructure, that could support not only just the process of productionization, but also this innovative experimental cycle will be very, very much more critical. And lastly, but not least, we started this journey of machine learning collaboration in 2019. And back then, there were really not many organizations experienced with the machine learning. And there were like only few individuals in each organization trying to use machine learning, but they experienced so much struggle because there were not many people in their organization doing machine learning. So the main purpose of this machine learning international group was and always has been to connect the people from different organizations, share experiences and lessons learned, share also sometimes failures, like Michael said in the morning, like showing dirty dishes in your kitchen sometimes, so that we can learn from each other, and as a community we can advance faster. And compared to 2019, I think there has been a lot of good progresses made. We see more methods being used, more discussion, concrete discussion around the production issues and so on. But we also see new organizations joining, starting experimenting with the machine learning. And also, obviously, there are new methods coming up and more use cases appearing. So I think there is still a need for knowledge sharing and capability building. So I think with that, I will now hand over back to you, Eric.
Thank you very much, Enkyoon. So I think we had a very interesting year on, and we made some great progress on that. So many people asking us what's next. So I think many activities should really continue in 2003. But of course, what we can't do is we can't continue in this similar format, and in this kind of capacity it will stop. And both UNECE, INCU in the team, and ONS, so that's Alison and the team, we need to really reallocate our resources to other projects. However, I like to think that we established a real good framework initiative here with, I think, well over 400 members now. And it's like anything in life. You need to continue. It's a bit like your corner shop. It only stays open if you shop there. So what I really like to think is that people continue to work on this, and that we continue to see like many people at the different events. And if we put a few examples up there, of course, we're really promoting this work at all kinds of different levels with the UN Center of Excellence of Big Data. We are just in the process of setting up a new data science leader network, which we very much going to look at the strategic level. And of course, machine learning will be a key part for that. From a more practitioner level, we also talking with the regional hubs that many have heard of you with the global platform, actually try to bring machine learning in those regions where the need is around the different topics. Web scraping is a popular one. We're looking a lot at agriculture data. Satellite data will be looked at. We also heard from Eurostat, apologies, that ESASnet is looking at to build a center of excellence around machine learning. So I think we will hear more about that in early of 2023. Of course, we will try to maintain the UNECE machine learning wiki space, which had like a vast amount of information. And of course, we have a confirmation now from INCU and the team that UNECE will run a expert meeting in June 2023. So there will be lots of continuation. It will be in a different format. I really hope that we can continue this work. We achieved a lot, but it's now much more coming to the application part. And I think what I like to see is that we continue to improve so that we can make sure that the production and of relevant statistics become relevant through the way of applying machine learning. So with that, I like to just hand over to Hannah now, which we're going to share some polls before I hand over to Mary for some final closing remarks. Okay, so we can see. So these are some polls we got back. So I think these polls will stay open for a while also after the seminar, and of course we'll write these up. So capacity ability to write review paper. Okay, so there's quite a lot of interest in that. Can we? And I'll always like to encourage people to give us that feedback and actually to see how we can take the different groups forward on this. But I think we for sure learned that's lots of interest into this, and I really like to think that small groups will continue, and that we'll see many of you again on the different events, just realizing that ML has become making still a big impact in your organization. So with that, I like to hand over to Mary. Mary Gregory is our Deputy Director at the Data Science Campus, will give us some closing remarks. Okay, Mary, the floor is yours.
Thank you, everybody. Really great to be part of the session and hear all the really great discussion and questions. I'm honoured to have this opportunity to say thank you to everybody, but also a bit sad it's the last meeting at the moment. There's clearly been a huge range and depth of topics covered in the webinars. The kind of creativity coming across is really good, and I hope lots of people are feeling like they can take lessons away and do really great things when they go back to their day jobs. I want to really congratulate the group on all you've managed to achieve in the years that it has been going. I think from its kind of starting point of 12 members to having hundreds of people on the call and kind of 400 in the membership today really just shows the value that this group has added. There are many people who it would be well worth thanking. I don't think we've got time to thank everybody, but I think it is well worth saying thank you to Eric and others in the team in ONS who I know have been really pleased to be able to contribute, and I'm very grateful to them for all their work. And also a particular thank you to Inky Young Choi, who has been the driving force behind the direction and success of the group. So thank you very much to all of you. I hope that through the discussion and through the ideas you've been putting forward, there will be ways to take forward some of the great work and make sure we benefit from the group that has come about. But whatever happens, I think we should be really reflect very positively on what's happened and the advancements that we've seen across official statistics internationally as a result of the work this has been undertaken in the group. So I guess do please continue to engage, do please make the most of those connections that you've built up through this work. And thank you very much to so many of you for making it all such a success. Many thanks.
Thank you very much, Mary. And I think it's interesting that what you've been seeing over the last, say, 6 months since you joined the campus on the interest around the globe is very similar, and that there's a need for that. But also there's what we want to ensure that there's from a campus perspective, but also with other organizations, that we also bridge that gap and that we make more people aware of what machine learning can help your organization with. So I really want to conclude, as Mario said, a massive thank you, particularly to Alison and Inky, who have been the driving force on this for many years, and the many people on the call. Some been involved for 1, some 2, some 3, some people have stuck out the whole 4 years, which is very interesting, because it doesn't happen often. I mean, I had some feedback last week from the event in Geneva that after Alison gave a presentation, they never had so much feedback before. So that shows there's a real interest in this, and I really like to think through the different working groups around the globe, we can really put this at our senior statisticians' agenda, that through technology and everything that's surrounded with that, we can continue to develop and produce relevant and official statistics. So with that, I'd like to close this session, and I look forward to see you at some point online, in person, and let's all stay safe. Thank you. Goodbye.